Good morning, good afternoon, and good evening. My cousin gave me this 3-in-1 USB charging cable. It goes from a USB-A to USB-C and the Apple old iPhone connector and micro USB. Anyway, he claims that this cable basically was dead on arrival. From the first time he tried it, he couldn't charge anything. And he said he tried it on USB-C and it didn't work, but I've tried it with USB-C and micro USB. Both did not work. Let me show you quickly at least the USB-C part. I'll plug it into my charger. Then I have an old phone here and USB-C. Nothing happened. On this phone, red lights should come on here, and obviously you should see a charging symbol, but there is no charging symbol. Okay, anyway, so this cable does not work. And on my meter it shows that it's not drawing any current. Anyway, so it took me a long time, but using a Dremel-like tool, I cut off two pieces. On the outside there was this plastic cover, which is similar to the cover that you see here on the bottom, but this one was here on the top part. But under this one there was also another plastic cover covering the electronics. So this was here, and then on top of the white plastic was the black plastic. Anyway, so I used the Dremel and I cut the edge here, and I removed both of them. It took a lot of work and patience. And while I was doing all that, I basically damaged a little bit of the cabling here. So you see some rough soldering to correct the problem. If I can get this working fully, I intend to cut this off and then re-solder new lines to get rid of this ugly soldering here. Alright, let's go under the microscope and I'll show you what I've discovered. So I started my testing by checking for continuity between these input lines, 1, 2, 3, 4, and the USB-A, which is at the input end of this cable. And I checked for continuity and all was well. So I could get a tone for each of these lines. Then I checked for continuity between the ground, which is right here, and the ground at the other end, because I saw that it went straight through. And there was continuity. Let me show you that part quickly. So here it says continuity. It's between here and here. So as you heard, there is continuity. So then I moved to the V plus pin, which is the red wire here. And so I saw that it went here and then through this component. I recognize this as a MOSFET because there's a 4, 3, and 1 pinout, which is typical for a MOSFET. And then from this end, it goes directly to the V plus here. So the strangest thing happened. I looked the datasheet up for this MOSFET to see whether it was an N channel or a P channel. Well, it turned out to be a P channel, and it has an internal diode that goes from drain to source. So I put the multimeter in diode mode, and I checked for that, like this, drain to source. And I didn't get a reading. I'm supposed to get a reading based on the datasheet. Now, I use a tiny bit of extra force here on the left side with my with my red probe, I mean. And so when I did that, look at this. The cover of this IC just came loose. It's the weirdest thing I've ever seen. Combine that with the fact that I can't get a diode reading. Let me try one more time. So I have the red probe on the drain here, the drain, and the black probe, which is this probe here, I have it on the source, and I'm supposed to get a diode reading. I'll put, if I haven't already done, I'll put the picture of the pinout for this chip. Anyway, so the conclusion is basically that I believe that this chip was faulty from manufacturing. And let me see, I think it's a 4435. Let me adjust the a bit more light. Yeah, it's a 4435B MOSFET, which, like I said, is a P-channel MOSFET. Since I'm convinced that this chip is faulty, I'm going to go ahead and remove it, and then I'll try and find a replacement. I'm going to set my hot air to 400 degrees Celsius, 50% airflow at an ST862D. And the chip is out. I'm going to cool the board down a tiny bit with my thermal pad. Alright, let me give it a quick clean with some isopropyl alcohol. So I spent quite a bit of time looking through my scrap boards, and I didn't find any MOSFETs that match this one. But then I remembered that I have a spreadsheet with all the components that I've bought over the years, and I did find that I had the 7405 P-channel MOSFET, which is similar in specs to the 4435B that's defective. This one, the 7405, has actually slightly better specs in some respects, and so it should work well. Alright, I'm going to test the new chip, the 7405. Just like the other one, it should have a diode reading between drain and source. So this big pad here is the drain, the top pin is the gate, and the three below it are all source. So drain, let me put this diode mode. So drain to source, we should see a diode reading. There we go. On any of these pins. Here's the second pin, and here's the third pin. So that's the diode reading. Now I'm going to turn the MOSFET on by making the gate negative relative to the source. So I'll just touch this pin here. Now there should be continuity between the drain and the source. So now we should hear a beep. There we go. And we have continuity. Now I will turn it off by applying a positive voltage relative to the source, like this. And now we should go back to seeing a diode reading. And what do we see? We see a diode reading, 0.546. Okay, so this MOSFET is a good one, and so I'm going to proceed to install it on the motherboard. I want to add some leaded solder to the pads, especially that drain pads, because it looks very dry. So let's do that. Now I'm going to come in with hot air at 400 degrees Celsius, 20% airflow. Yeah, it's going like this. Add a tiny bit of flux. I'm going to get rid of that solder blob on the left hand side. Holding well. Yeah, it's pretty darn solid. Okay. Bit of a cleanup while the board is still hot. Yes. Alright, I'm gonna go ahead and check the diode again. Out over there. So drain to source, we have to see a diode reading. Drain to source. Yeah, 0.495, and it's going up, and it will continue going up as the board cools down. So I suspect this cable is now repaired. Okay, time for a test. I've already plugged it in from the other end, and here we go. No, no, it's not charging. Same as before. There is no charging symbol and no red LED on the phone. So that did not fix it. Alright, so still no solution, but I've made some interesting discoveries. So this is the chip that we replaced. Basically, the MOSFET is not turning on. So I can measure here 5 volts, but I don't get 5 volts here on the drain. So basically the gate is not getting a low signal, because the gate needs to be negative relative to the source for it to enable this MOSFET and then take whatever voltage is here and put it on the drain. Well, that's not happening. But I was able to sort of make it work by jumping these two paths, this here and this here. Basically, I'm making the source connected to drain, simulating the MOSFET being turned on. The other way I am able to also do it is by shorting the gate here to ground here. And yes, I did redo the cables in my desperation to find a solution, but that didn't make a difference. So right now I'm going to show you when I short these 2 points together, you're going to see a red light here on the phone. And I'll switch to the overhead camera so you can see it more clearly. And then I'm going to short the gate here to ground, and again you're going to see the red light here on the phone. Alright. Okay, I plugged it in, and so let me first short these 2 points. I don't know if you can see the red light. Let me switch to the okay, and turn it on, and it says charging. Now when the screen goes off, the red light returns. Now I'm removing my tweezer for the short, and as you can see, it no longer says charging, and the red light is gone. Okay, so that was with shorting these 2 points. Now I'm going to short the gate, as I explained a moment ago. I'm going to short the gate of this MOSFET to ground, simulating basically turning on the MOSFET. So, gate to ground. Red light is on. Let me switch you. Red light is on. I'm on the phone. Charging. Red light is on. Now I'm going to remove the tweezer. This one stays longer. The light will stay on longer, but it will eventually turn off. Removing the tweezer now. See, it stays on a little longer. Eventually, well, when I did my test, it turned off. Now it seems to be staying on for some reason. Okay, but I'm pretty sure that's not fixed. And to prove it, I'm going to disconnect here. Okay, let the screen turn off. Okay, I'm going to connect again, and it's not going to be charging. Oh, what's going on? It turned on. Okay, I'm going to unplug from the power, from the main source, and then replug from the main source. Maybe that will make a difference. Okay, I unplugged from the main source. Okay, and I'm also going to unplug from here. Alright, which one should I do for, I'll plug the main source. Okay, and then let me plug here. Oh my god, and it's drawing, well, 310 milliamps, but you know, that's a different story. And it is charging. Okay, I'm gonna stop recording for a moment. Let me see what's going on. It seems to be working now. I'll be back in a minute. Alright, and we're back to it not charging. It's been like a minute. I unplugged it, replugged it, and now it doesn't charge. Okay, I'm gonna plug it now. Nothing happens. No red light. And I would need to... Let me jump these pads, since these are just temporary. So, jump these. Yeah, red light. I can see it. Maybe you can see it also on the small window. Remove it, and back to not charging. But the gate seems to, when I short the gate to ground, it seems to last longer, or somehow it makes it work. Let's do that one more time. Gate, and then short this. Okay, the light is on. I'm going to remove the tweezer quickly. No, it stopped. So it came on briefly and then it stopped. Let me short it a bit longer this time. Wait. Okay, it's on. I'm going to keep it there for a while. Keeping it on. It's around 500 milliamps currently. I have an ammeter. Okay, I'm going to remove the tweezer. And no, it stopped instantly. So I don't know what fluke that was the first time. So sadly, I will not be able to repair this cable. I'm quite disappointed, to say the least. I put a lot of effort into it. Not for the value of the cable. This cable costs only like $9, but I do enjoy repairing stuff. And with my limited knowledge in electronics, I can't figure out why the MOSFET is not switching on. If you have any ideas and you'd like to point me in the right direction, I'm going to save this cable, and if I get any useful tips, I'll try to repair it again. But in the meantime, I hope you enjoyed this video, and see you on the next one. Bye bye.